Figure 7.13, Static Array Initialization and Automatic Array Initialization. In a previous example, we talked a little bit about scope of variables, and we talked about static local variables in particular. And a couple of times now we've talked about the fact that by default, C++ does not initialize variables for you. In the case of a class, you can get initialization of a variable at the time you create it by specifying a constructor that does the initialization. And separately, for primitive type or fundamental type values, they do not get initialized by default. However, there are, like I said, a couple of exceptions to that rule. For example, in an earlier video of this lesson, we showed you that if you use an array initializer list and you don't provide enough initializers for the number of elements in the array, the remaining elements will be initialized to 0 in memory, and therefore they will get some default initialization. Another case where you get some default initialization is with static local arrays. So in this example, what we want to do is just demonstrate the static local array concept, and we have actually two different functions we'll be looking at, one called static array init and one called automatic array init. And by the way, these void keywords are not required here, because in C++, if you have an empty parameter list, you can simply specify empty parentheses. So I'll go ahead and get rid of those for the moment. Now, in the main part of this program, you can see that we're going to call static array init, and then we're going to call automatic array init. The static array init method, or function rather, is going to have in its body a statically declared local array, and the automatic array init will have a local array that's not declared static, which means every time that function gets called, that array will be recreated. Remember, when you have a static local variable, the item gets created once at the time that you first encounter its declaration, and then it exists for the rest of the program. So let's take a look at first our call to static array init. And you can see here in lines 25 through 41, static array init first starts out by declaring a static local array of integers called array1 with 3 elements. Now, here is one of the exceptions to the rule with respect to variables not getting initialized. When you declare a static local array, the elements of the array will be initialized the first time the function is called to 0 unless you specify otherwise by providing an initializer list. So in this case, we actually wind up with an array of 3 zeros, and we're going to display those elements for you, and I'll run the program in a moment to show you that. Then we're going to modify each of the elements in the array with this highlighted expression that's going to add 5 to each individual element, thus modifying the elements. So as we enter the function the first time, the values will be set, or the elements will be set to 0 automatically, and then as we leave the function, each of those elements will have the value 5 because we're going to be modifying them. So let's run the program so we can look at that part of the output here. And you can see that when we first entered static array init, the elements of the array were set to 0 explicitly, and as we leave, each of the elements is set to 5. We'll come back to this output window in just a moment. Next, we call automatic array init, and when I go to the definition, let's try that one more time. Go to the definition of the function. You can see here that the automatic array init function also declares an array locally. This one is not declared static, which means by default it would not get initialized, but we did provide an initializer list here so that the elements of the array have the values 1, 2, and 3 respectively. After that, we display those values, and then we modify each of the values before we leave, adding 5 to each element. And as you can see here, when we first entered the function, we have the values 1, 2, and 3 as the values of that array, and as we leave, we have 6, 7, and 8 as the values. However, because this is not a static array, as we reach the closing curly brace of this function, the array is removed from memory, it no longer exists, which means when this function gets called the next time, we'll recreate that array. So back up in main, we call each of the functions a second time, first calling static array init, and just like with a static local variable, a static local array still exists when you call the function subsequent times. So line 28 is ignored. We display the current values in the array, and then we modify and display those values again. And if I take a look at the output, you see here that when we enter this time, the array elements are 5, which is what they were when we left last time. And now by adding 5 to each element, each value is 10. And then finally we call automatic array init again. And when we take a look there, because this is a non-static local array, it's recreated from scratch. It has now the values 1, 2, and 3 again. We display those values, and then we modify them and display them again. And you can see here 1, 2, 3 as we enter the function, just like it was the last time, and 6, 7, 8 as we leave, just like it was the last time.